Hello viewers, in this video lecture, today we are going to talk about the module Power Generation Technologies, in which we are going to learn about lecture 4, Proximate and Ultimate Analysis of Coal. In the previous lecture, we have learned about types of fuel. So viewers, today we will deal with the proximate and ultimate analysis of coal. Here are the important topics which will be discussed in this video. Fuels and its classification, coal, impact of coal, properties of coal, analysis of coal, proximate analysis and ultimate analysis. Summary: fuels. A fuel is a combustible substance containing carbon as a main constituent, which on proper burning gives large amount of heat that can be used economically for domestic and industrial purposes. During the process of combustion of a fuel, the atoms of carbon, hydrogen, etc. combine with oxygen with the simultaneous liberation of heat. So, carbon compounds have been used for many centuries as the source of heat and energy. The main source of fuel is coal and petroleum. These are stored fuels available in the earth's crust and are generally called fossil fuels because they were formed from the fossilized remains of plants and animals. The various types of fuels like liquid, solid and gaseous fuels are available for firing in boilers, furnaces and other combustion equipment. The selection of right type of fuel depends on various factors such as availability, storage, handling, pollution and landed cost of fuel. The knowledge of the fuel properties helps in selecting the right fuel for the right purpose and efficient use of the fuel. The following characteristics determined by the laboratory tests are generally used for assessing the nature and quality of fuels. Now, let us discuss about classification of fuels. Primary fuels which occur in nature such as coal, petroleum and natural gas. Secondary fuels which are derived from the primary fuels, example coke, gasoline, coal gas, etc. Both primary and secondary fuels may be further classified based upon their physical state as solid fuels like coal, wood, biomass, liquid fuels, petroleum oil, gaseous fuels, natural gases, coal. Coal is registered as a fossil fuel produced from large accumulation of vegetables, debris due to partial decay and acceleration by the action of heat and pressure over millions of years. Coal is highly carbonaceous matter which has been formed as a result of alteration of vegetable matter, example plants, under certain favorable conditions. It is chiefly composed of carbon, hydrogen, nitrogen and oxygen besides non-combustible inorganic matter. Now, classification of coal. Coals are classified on the basis of their rank. Rank is defined as the degree of extent of maturation and is therefore a qualitative measure of carbon contents. Peat, lignite and subbituminous coal are referred as a low rank coal, while bituminous coals and anthracites are classified as rank in a European technology. The lignite and subbituminous coals are called soft coals, while bituminous coals or anthracite coals are termed as hard coals. In North American terminology, the coal series is written as wood, peat, lignite, bituminous, anthracite. There are four main types of coal: lignite coal, subbituminous coal. Lignite coal can be defined as this is the lowest rank of the coal and is softest and least dense. It has a high moisture content and a low heating value. Subbituminous coal, this is a bit harder than lignite and has a higher heating value. It is used to generate electricity and heat homes and business. Bituminous coal, this is the most common type of coal and used to generate electricity. Anthracite, this is the highest rank of the coal and is the hardest and most dense. It has very high heating value and is used to make steel. The use of coal has number of environmental impacts including air pollution. The burning of coal releases pollutants into the air such as sulfur dioxide, nitrogen oxide and particulate matter. These pollutants can cause respiratory problems, heart disease and cancer. Water pollution. The mining of coal can pollute water bodies with sediments, heavy metals and other contaminants. This can harm aquatic life and make water unsafe for drinking and recreation. Climate change. The burning of coal releases greenhouse gases into the atmosphere which contribute to climate change. Now, properties of coal classification. Coal is classified into three major types, namely anthracite, bituminous and lignite. However, there is no clear demarcation between them and the coal is also further classified as semi-anthracite, semi-bituminous and subbituminous. Anthracite is the oldest coal from geological perspective. It is a hard coal composed mainly of carbon with little volatile content and practically no moisture. Lignite is the youngest coal from geological perspective. It is a soft coal composed mainly of volatile matter and moisture. The common coals used in the Indian industry are bituminous and subbituminous coal. The gradation of Indian coal based on its calorific value is as follows. Normally, D, E, F coal grades are available to Indian industry. The chemical composition of coal has a strong influence on its combustibility. The properties of coal are broadly classified as physical property, heating value. The heating value of coal varies from coal field to coal field. Measurement of moisture. Determination of moisture is carried out by placing a sample of powdered raw coal of size 200 micron size in an uncovered crucible and it is placed in the oven kept at 108 plus minus 2 degrees centigrade along with the lid. Then the sample is cooled to the room temperature and weighted again. The loss in weight represents moisture. Measurement of volatile matter. Fresh sample of crushed coal is weighted, placed in a covered crucible and heated in a furnace at 900 plus minus 15 degree centigrade. For the methodologies, including that for carbon and ash, refer to IS 1350 part 1:1984 part 3 part 4. The sample is cooled and weighted. Loss of weight represents moisture and volatile matter. The remainder is coke, fixed carbon and ash. Measurement of carbon and ash. The cover from the crucible used in the last test is removed and the crucible is heated over the Bunsen burner until the carbon is burnt. This residue is weighted, which is the incombustible ash. The difference in the weight from the previous weighted is the fixed carbon. Fixed carbon is the solid fuel left in the furnace after volatile matter is distilled off. It consists mostly of carbon, but also contains some hydrogen, oxygen, sulfur and nitrogen, not driven off with the gases. Fixed carbon gives a rough estimate of the heating value of coal. Volatile matter, the methane, hydrocarbons, hydrogen and carbon monoxide and incombustible gases like carbon dioxide and nitrogen found in the coal. Thus, the volatile matter is an index of the gaseous fuel present. A typical range of volatile matter is 20 to 35%. Volatile matter proportionately increases flame length and helps to easier ignition of the coal. Sets minimum limit on the furnace heat and volume. It influences the secondary air requirement and distribution aspects. It influences the secondary oil support. Ash content. Ash is an impurity that will not burn. Typically range of ash is 5% to 40% ash. It reduces handling and burning capacity. It increases handling cost. It affects combustion efficiency and boiler efficiency. It causes crinkling and slagging. Now, let us summarize why the proximate and ultimate analysis of coal are very important for us when we are using thermal power plant. India is a country which is dependent 80% on thermal power plant. So, it is very important to classify our fuels, types of fuels and ultimate and proximate analysis of coal. The proximate analysis of coal is a technique used to analyze the moisture content, ash content and fixed carbon content of the coal, whereas ultimate analysis of the coal is the technique used to analyze the chemical composition of the coal. When we analyze proximate and ultimate analysis of coal, it is easier for us to determine what is our fuel, what is our coal and how much it has its value. It will be easier for us for the production process. Proximate analysis is often used to classify coals and ultimate analysis is used to calculate heating value of the coal and to assess its environmental impact on the society. We have also dealt with the examples of how proximate and ultimate analysis of coals can be used. Coal has an effect on pollution. It creates harmful effect on pollution. It has pollution effects like air pollution, water pollution and land pollution. The environmental impact of coal combustion by determining the amount of sulfur, nitrogen that are released into the atmosphere is very high. Analysis of coal. There are two methods, ultimate analysis and proximate analysis. The ultimate analysis determines all coal component elements, solid or gaseous, and the proximate analysis determines only the fixed carbon, volatile matter, moisture and ash percentages. The ultimate analysis is determined in a properly equipped laboratory by a skilled chemist, while proximate analysis can be determined with a simple apparatus. It may be noted that proximate has no connection with the word approximate. What is proximate analysis of coal? Proximate analysis of coal is the process of determining the presence of different compounds and their amounts in the coal. The technique of proximate analysis was developed by Handbridge and Stordman, German scientists in 1860s. This analysis technique involves the partitioning of compounds into different categories depending on chemical properties of these compounds. Mainly, there are 6 categories of compounds as moisture, ash, crude protein, crude lipid, crude fiber and nitrogen free extracts. In the process of proximate analysis of coal, the moisture content of the coal, ash content of coal and the fixed carbon content of coal are determined. Now, you people might have question in your mind, what is proximate analysis? Let us deal with proximate analysis. Proximate analysis indicates the percentage by weight of the fixed carbon, volatiles, ash and moisture content in the coal. The amounts of fixed carbon and volatile combustible matter directly contribute to the heating value of the coal. Fixed carbon acts as a main heat generator during burning. High volatile matter content indicates easy ignition of fuel. The ash content is important in the design of the furnace grate, combustion volume, pollution control equipment and ash handling system of a furnace. A typical proximate analysis of various coal is given in the table. It is shown. Significance of various parameters in proximate analysis. First, fixed carbon. Fixed carbon is the solid fuel left in the furnace after volatile matter is distilled off. It consists mostly of carbon, but also contains some hydrogen, oxygen, sulfur and nitrogen not driven off with the gases. Fixed carbon gives a rough estimate of heating value of coal. Volatile matter. Volatile matters are the methane, hydrocarbons, hydrogen and carbon monoxide and incombustible gases like carbon dioxide and nitrogen found in the coal. Thus, the volatile matter is an index of the gaseous fuel present. Typical range of volatile matter is 20 to 35%. Volatile matter proportionately increase flame length and helps in easier ignition of coal. Sets minimum limit on the furnace height and volume. It influences secondary air requirement and distribution aspects. It influences secondary oil support. Now, let us see a bit about ash content. Ash is an impurity that will not burn. Typical range is 5 to 40% of ash. It reduces handling and burning capacity. It increases handling costs. It affects combustion efficiency and boiler efficiency. It causes crinkling and slagging. D. Moisture content. Moisture in a coal must be transported, handled and stored since it replaces combustible matter. It decreases the heat content per kg of coal. Typical range is 0.5 to 10% of moisture. It increases heat loss due to evaporation and superheating. It helps to limit in binding fines. It aids radiation heat transfer. Now, let us discuss about sulfur content. Typical range is 0.5 to 8% normally. Sulfur affects crinkling and slagging tendencies. It corrodes chimney and other equipment such as air heaters and economizer. It limits exit fuel gas temperature. Now, you people might have question in your mind, what is ultimate analysis of coal? Now, the ultimate analysis of coal is the process of determining different chemical elements present in coal. This technique allows us to get more comprehensive results compared to proximate analysis process. In this analysis technique, we test moisture, ash, carbon, hydrogen, nitrogen, sulfur and oxygen content of the sample to determine the eliminated composition of the coal sample. Therefore, each and every chemical element in the sample is analyzed through chemical routes and then we can express the contents as percentage with respect to total mass of the sample. Mostly, this analysis technique is useful in the coal and coke industry. Ultimate analysis. The ultimate analysis indicates the various elemental chemical constituents such as carbon, hydrogen, oxygen, sulfur, etc. It is useful in determining the quantity of air required for combustion and the volume and composition of the combustion gases. This formation is required for the calculation of flame temperature and the flue duct design, etc. Typical ultimate analysis of various coals are given in this table. Carbon and hydrogen about 1 to 2 gram of accurately weighted coal sample is burnt in a current of oxygen in a combustion apparatus. C and H of the coal are converted into CO2 and H2O respectively. The gaseous products of the combustion are absorbed respectively in KOH and CaCl2 tubes of known weight. The increase in weights of these then determined. Now let us discuss about nitrogen. About 1 gram of accurately weighted powder coal is heated with concentrated H2SO4 along with K2SO4 catalyst in a long necked kg/Celsius flask. After the solution becomes clear, it is treated with excess of KOH and liberated ammonia is distilled over and absorbed in a known volume of standard acid solution. The unused acid is then determined by back titration with standard NOH solution from the volume of acid used by ammonia liberated. The percentage of nitrogen in coal is calculated as follows. Sulfur. Sulfur is determined from the washing obtained from the known mass of coal used in bomb calorimeter for determining of a calorific value. During this determination, S is converted into sulphate. The washing and treated with barium chloride solution when barium sulphate is precipitated. This precipitation is filtered, washed and heated to constant weight. Ash. The residual coal taken in a crucible and then heated without lid in a muffling furnace at 700 degrees centigrade for half an hour. The crucible is then taken out, cooled first in the air, then is desiccator and weighted. Heating, cooling and weighing are repeated till a constant weight is obtained. The residual is reported as ash on the percentage basis. Next, let us deal with oxygen. Oxygen is determined indirectly by deduction the combined percentage of carbon, hydrogen, nitrogen, sulfur and ash from 100. Significance and ultimate analysis. Carbon and hydrogen. Greater the percentage of carbon and hydrogen, better is the coal in quality and calorific value. However, hydrogen is mostly associated with volatile matter and hence it affects the use to which the coal is put. Nitrogen has no calorific value and hence its presence in the coal is undesirable. Thus, a good quality coal should have little nitrogen content. Sulfur. Sulfur although contributes to the heating value of coal, yet on combustion products, acids like SO2, SO3 which have harmful effects of corroding the equipment and also cause atmospheric pollution. Sulfur is usually present to an extent of 0.5 to 0.3% and derived from ores like iron, pyrites, gypsum, etc. Mines along with the coal. Presence of sulfur is highly undesirable in coal to be used for making coke for iron industry, since it is transferred to iron metal and badly affects the quality and properties of steel. Moreover, oxides of sulfur pollute the atmosphere and leads to corrosion. Ash. Ash is a useless non-combustible matter which reduces the calorific value of coal. Moreover, ash causes the hindrance to the flow of air and heat, thereby lowering the temperature. Hence, lower the ash content, better the quality of coal. The presence of ash also increases transporting, handling and storage costs. It also involves addition cost in ash disposal. The presence of ash also causes early wear of furnace walls, burning of apparatus and feeding mechanism. Oxygen. Oxygen content decreases the calorific value of coal. High oxygen content coals are characterized by high inherent moisture, low calorific value and low cooking powder. Moreover, oxygen is combined form with hydrogen in coal and thus hydrogen available for combustion is lesser than actual one. An increase in 1% oxygen content decreases the calorific value by about 1.7% and hence oxygen is undesirable. Thus, a good quality of coal should have a low percentage of oxygen. Now, what is difference between proximate and ultimate proximate analysis of coal? Proximate analysis and ultimate analysis techniques are related to each other. The key difference between proximate and ultimate analysis of coal is that the proximate analysis of coal is the technique used to analyze the moisture content, ash content and fixed carbon of coal, whereas the ultimate analysis of coal is the technique used to analyze the chemical composition of coal. Generally, the ultimate analysis gives more comprehensive results compared to proximate analysis. Proximate analysis is a relatively quick and easy test to perform and it provides a good overview of the composition of coal. Ultimate analysis is a more complex test, but it provides more detailed information about the elemental composition of coal. The following table summarizes the key difference between proximate and ultimate analysis of coal. Now, let us summarize proximate versus ultimate analysis of coal. Proximate analysis of coal is the process of determining the presence of different compounds and their amounts in coal. Ultimate analysis of coal, on the other hand, is the process of determining different chemical elements present in the coal. Therefore, the key difference between proximate and ultimate analysis of coal is that proximate analysis of coal is the technique used to analyze the moisture content, ash content and fixed carbon contents of coal, whereas ultimate analysis of coal is the technique used to analyze the chemical composition of coal. Both proximate and ultimate analysis are important tools for understanding the properties of coal and for evaluating its suitability for different applications. Proximate analysis is often used to classify coals, while ultimate analysis is used to calculate the heating value of coal and to assess its environmental impact. Here are some examples of how proximate and ultimate analysis can be used. Proximate analysis can be used to classify coals as bituminous, subbituminous or lignite. Ultimate analysis can be used to calculate heating value of coal, which is the amount of heat that is released when coal is burnt. Ultimate analysis can be used to assess the environmental impact of coal combustion by determining the amount of sulfur and nitrogen that are released into the atmosphere. Now, let us summarize today's video session. Today, we have learnt fuels and its classification, coal, impact of coal, properties of coal, analysis of coal, proximate analysis, ultimate analysis and summary. And I hope I have dealt in detail with all these contents. So, I suppose you must have had a good learning experiences watching this video. So, keep watching and enjoy learning. Thank you.